Hello again, Algebra 1 students. We're back into our Unit 3, Week 2 syllabus, the family of functions, and we are in Tier 1, Lesson 2, given an absolute value function. Again, I just want to explore these functions and do some inputs and outputs and kind of draw them on the Cartesian plane with you guys. So again, I always like to start with the easiest of inputs. So I like to go 0, and then 2 points to the right, and then 2 points to the left. If I plug in -2 into my absolute value function, and remember, f of x is just a fancy way of doing y for my output. An absolute value, if you remember from middle school, is just a distance from 0. I'm going to shrink that down. It's noted by the bars like this on the side. These little guys right here. All that means is how far is that number from 0. So if I plug -2 into my absolute value function, well, -2 is 2 away from 0 on the number line. -2, the absolute value of -2 is just 2. If I plug -1 into the x here, then -1 is 1 unit away from 0. If I plug 0 into the absolute value function as my input, then my output again will be 0 because 0 is at 0 on the number line. And then if I go the other way and have 1 and I plug that into the absolute value function, then 1 is 1 unit away from 0 on the number line. And if I input 2 into my absolute value function, my output also will be 2 because 2 is 2 units away from 0. So let's graph this. -2, 2. So I come back 2 and I go up 2. And that's my first point right there in that ballpark. And then -1, 1 is my next point. So I come back 1 and I come up 1. And then 0, 0. This point is called the origin. I'm going to write that down. 0, 0. This is called the origin. And then 1, 1 is my next point, 1, 1, right 1, up 1, and then 2, 2 is my last point, right 2, up 2, and that gives me this point right here. Now we can sketch this. And what's cool about an absolute value function is that it looks like a V. As we look at this sketch, we can make a couple little things here. First of all, if you remember from the previous here, when we were talking increasing and decreasing, with lines, a line is either always increasing or always decreasing. With absolute values, there's two different sections. There's an increasing section when you read left to right, it going up. And then there's also a decreasing section when you read left to right, it going down. Okay. And then this is a really important feature, is this thing right here in the middle where it changes from increasing to decreasing. That's called the vertex. And it has a point. And in this situation, our vertex is at the origin. And I told you that the origin is 0, 0. So when we're talking about increasing or decreasing with absolute values, the vertex is a very important point because that's where it changes the interval. Interval is a fancy way of saying where's it increasing from and where's it decreasing from. I'm going to write this down and shrink it for you guys. And I suggest you write it. When you're talking about intervals, or only look at x values. With intervals, y values don't matter. So I want to highlight this. I want you guys to be aware of this. This is super important. You should write this down and put it in your book. So knowing that I'm only dealing with x values, let's find my increasing. Well, I start increasing right here at the origin, and then I increase all the way, and this arrow means I go on forever. So the x value at the origin right here is 0. That's where I start increasing. And then my x value all the way out here forever and ever and ever, if you guys remember from middle school, the largest positive number we can have is infinity. So my increasing interval is going to be from 0 to infinity with this absolute value function. Now here's my decreasing interval. And my decreasing interval ends at 0, 0 because that's where I stop decreasing. So I stop decreasing at the vertex. So my right point would definitely be 0 because that's where I stop decreasing. But I start decreasing all the way out here to the left. And remember, we're only looking at the x values. So all the way out here to the left, the smallest x value is -infinity. So our decreasing interval, it starts decreasing all the way out where it begins at -infinity and stops decreasing at 0. Let's look at another example. So again, when I'm choosing my inputs, I want to stay simple. 0, 1, 2, -1, -2. I'm going to go a little faster with my inputting. Input -2, the absolute value of -2 is 2, -3, my output is -1. Input -1, absolute value of -1 is 1, -3, my output is -2. I input 0, the absolute value of 0, 0, -3, my output is -3. I input 1, the absolute value of 1 is 1, -3, my output is -2. I input 2, the absolute value value of 2 is 2 minus 3. My output is -1. So now I have my points on my table that I can go graph. So my first point is -2, -1. So back 2, down 1. Then -1, -2, back 2, down 2. Then 0, 3, stay at 0, come down to -3. 1, -2, and then 2, -1. Right 2, down to -1. And if we look here, I have my V shape again in my absolute value function. A little bit different place, and that's okay. But again, all we're going to look at is try to find the vertex. Or if you remember, the vertex is where we said the graph changes from going from increasing to decreasing. So my vertex is right there at the point, or where the graph makes a point. So if we look here, my x value is 0 and my y value is -3. So my vertex in this absolute value function would be 0, -3. And then when we're looking at intervals, again, with positive interval, we want to look at when the graph is going up left to right, and with negative interval, we want to look at when the graph is going down left to right. And recall what I told you, that intervals are all about the x values. Y values don't matter. So my increasing, I start increasing at the vertex. So the x value at the vertex, again, is just 0. So I start increasing at 0. So I start increasing at 0. And then it goes on forever. That's what this arrow means, all the way out here to the largest x value that we know, which is positive infinity. Now looking at the decreasing side, when I start reading my decreasing side, this graph starts all the way out here at -infinity. So I start decreasing at -infinity, and then I decrease, and I bang, I hit the vertex. My x value at the vertex is 0, so that is where I stop decreasing. So my increasing interval is 0 to infinity. My decreasing interval is -infinity to 0. Let's look at one more example. I'll go a little faster, but you guys can pause it if you need to or rewatch it. Again, I always like to start with easy inputs. So 0, 1, 2, and then -1, -2 on the back side. So if I plug in -2, I get the absolute value of -2, but I also still have this little dude outside, so that little negative. So the absolute value of -2 is 2, but then I have to apply that negative. So I got -2 plus 4, which gives me 2. Then I have put in the absolute value of -1. The absolute value of -1 is 1. However, when I apply that negative out in front of the absolute value expression, then I get -1 plus 4, which is 3. When I plug in 0, well, the absolute value of 0, 0, 0 can't be negative, so when I plug in 0, my output is 4. When I plug in 1, the absolute value of 1 is 1. However, I got to apply that negative that's on the outside, which gives me -1 plus 4, which is 3. When I input 2 into this absolute value equation, I get the absolute value of 2, which is 2. Don't forget about the negative out in front, which makes it -2 plus 4, which gives me +2. So let's graph our points. -2, 2, -1, 3, 4, 0, 1, 3, and then 2, 2. Let's sketch our graph. So here we can see that the absolute value function looks a little different than the ones previously. If you look up here, we have a v that's upright. Down here, the v is flipped upside down. What's happening here is this negative that's out in front of the absolute value function actually flips it upside down. So it actually flips the v. So what that's going to change for us is where our increasing and decreasing intervals begin and end, and how we read them. So let's start with the vertex again. And remember, the vertex is just the point of the v. So our vertex, our x value is 0, and our y value is up 4. So that's our vertex. And remember, when we're dealing with increasing and decreasing intervals, we're talking about x values only. So let's look at increasing. Increasing from left to right and going up. Well, we start all the way out here and we go up to the vertex. That's our increasing. So the very smallest number all the way over here to the left on the x-axis is -infinity. So we start at -infinity. Where do we stop increasing? Well, we're increasing. Oh, we stop right here at the vertex again. Well, the x value of the vertex is 0. So our increasing interval is -infinity to 0. To talk decreasing, we want to talk about when the graph is going down, going left to right. And we can see that it starts decreasing at the vertex. Well, our x value at the vertex is just 0. And it never stops decreasing. It decreases forever all the way out to the right of the graph, which the largest x value that goes on forever is infinity. So our decreasing interval will be 0 to infinity. I know I introduced a lot of new material right here to you. Struggle through your practice sets. If you have questions, ask your neighbor. If they can't help you, both of you come see me. We'll get through this together. It's some new stuff for you guys. We'll explore it multiple times. Don't worry about it. Struggle and fail forward. Good luck on your practice sets.